Hello everyone, welcome to a video lecture on basics of LTE or 4th generation mobile network. I am K.R. Biradar, Assistant Professor, Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Let us start with the learning outcomes first. At the end of this video, you will be able to apply the features of LTE to analyze improvements over previous wireless generations. Introduction. LTE stands for long-term evolution. The long-term evolution is a 4th generation mobile network, also called 4G network. It was introduced and started projects on these networks in the year 2004. LTE came as a successor to the older technologies like UMTS and CDMA 2000. UMTS stands for Universal Mobile Telecommunication System. It is a 3rd generation mobile cellular system based on the GSM or Global System for Mobile Standard. Also, UMTS provides higher data rates and improved services like video calling, mobile internet and multimedia applications. But CDMA is a code division multiple access and provides 3rd generation mobile network. LTE improves the better speed and efficiency in the communication. One key requirement is that all LTE devices must support MIMO, multiple input, multiple output. That means LTE uses multiple antennas to increase data speed and accuracy. Voice over IP, that is also called VoIP. This allows voice calls to be transmitted over Internet protocol. Streaming multimedia, like watching videos or listening to music smoothly online. Video conferencing, supporting real-time communication. In simple words, LTE is a new technology that delivers triple play services, meaning it can handle voice, video and data all together. Stay connected, flexibility to connect multiple devices. Goals of LTE. The main goals of LTE are to provide high data rates, that means faster internet, to reduce latency, that is delay to be reduced, making communication real time, to achieve packet optimization, which means efficient use of network resources. LTE basic parameters. The various LTE parameters are discussed in the following slides. Frequency reuse. LTE supports scalable bandwidth from 1.4 MHz up to 20 MHz, making it flexible for different operators depending on available spectrum. Wider bandwidth allows higher data rates and better efficiency. Mobility, second one. LTE is designed to support high mobility environments, even for users traveling at speeds up to 350 km per hour, for example in high speed trains like bullet train. This ensures reliable connectivity for both low speed, that is walking speed, and high speed users. Coverage. LTE provides a wide coverage area ranging from 5 km up to 100 km. However, behind 30 km, signal quality slightly degrades due to propagation loss and timing issues. Fourth one, latency. One of the major advantages of LTE is its low latency. End-to-end delay is less than 10 milliseconds, enabling smooth real-time applications such as video calling, online gaming, and voice over IP. Fifth one, data rates. LTE provides very high data rates. Peak downlink speed can be reached 100 Mbps or more, while uplink speeds can go up to 50 Mbps. LTE supports two duplexing modes: FDD, frequency division duplexing, separate frequency bands for uplink and downlink; TDD, time division duplexing, uplink and downlink share the same band but are separated by time slots. Seventh one, accessing techniques. LTE uses OFDMA, that is orthogonal frequency division multiple access, for downlink, that is highly efficient and supports multiple users simultaneously. SCFDMA, single carrier frequency division multiple access, is used in uplink, reduces power consumption in user devices. Eighth one, modulation. LTE adopts modulation schemes based on channel quality. QPSK, quadrature phase shift keying, robust but lower data rates. 64 QAM, higher data rate but requires good signal conditions, accessing techniques. Coding, ninth one. LTE uses channel coding techniques like turbo coding for error correction. This ensures reliable transmission even noisy environments. MIMO, 10th one. Multiple input, multiple output. LTE supports MIMO technology, uses multiple antennas at both transmitter and receiver. This improves capacity, data rates, and reliability of wireless links. Data rates in LTE. First one, downlink data rate. In LTE, the downlink peak data rate can reach 300 Mbps. This is achieved with a 20 MHz channel bandwidth and using 4x4 MIMO, multiple input, multiple output, which allows multiple data streams to be transmitted simultaneously, boosting speed and efficiency. The downlink is higher because the base station has more power and advanced antennas compared to user devices. Second one, uplink data rate. For the uplink, LTE supports a peak data rate of 75 Mbps under the same 20 MHz bandwidth and 4x4 MIMO configuration. The uplink speed is lower than downlink because mobile devices have limited transmission power and simple antenna systems compared to base stations. Duplexing and accessing techniques. Duplexing, which refers to how uplink and downlink transmissions share the same spectrum. LTE supports two modes. One is frequency division duplexing. Here, uplink and downlink use separate frequency bands. This allows both uplink and downlink to operate simultaneously at peak capacity without interference. It is suitable for scenarios with balanced traffic needs. Time division duplexing. Uplink and downlink share the same frequency band but are separated with time slots. This means uplink and downlink cannot both reach peak capacity at the same time. It is more flexible and spectrum efficiency, especially when traffic is symmetric. Here there is a question: In LTE, which duplexing method allows uplink and downlink to reach peak traffic simultaneously? The options are A. TDD, B. FDD, C. OFDMA, D. SCFDMA. Pause the video and try to think and answer for this question. The correct answer is B, that is frequency division duplexing. These are the references I refer to prepare the above presentation. Thank you.